From the Library of Congress in Washington, D.C.
Good morning and welcome to the second day of the Library of Congress's conference, Facts or Fictions, Debating the Mysteries of Early Modern Science and Cartography, a celebration of the 500th anniversary of Waldseemüller's 1516 Carta Marina. I'm Mark Sweeney, the Associate Librarian for Library Services. I hope a lot of you were able to join us yesterday. Needless to say, our distinguished speakers enlightened us about many crucial, intriguing aspects of Renaissance cartography and illustrated their remarks with images of maps of enormous significance for our greater appreciation of the quest to explore and understand the physical world. Last night, we also had the pleasure of learning about the mapping of the elusive southern sky, which was the subject of the annual J.I. Kislak lecture, brilliantly presented by Deva Sobel. Today, the examination of Renaissance cartography continues with more exciting presentations and discussions, as well as an open house at the Geography and Map Division. I hope you can stay with us throughout the remainder of the day. At this time, it's my privilege to introduce the 14th Librarian of Congress, Dr. Carla Hayden. As you may know, Dr. Hayden was sworn in as librarian on September the 14th. So unless I'm mistaken, I believe this is her first appearance today and participation in an international conference as Librarian of Congress. So please join me in welcoming one of the brightest stars in the firmament of the world's libraries, Dr. Carla Hayden. Thank you.
Well, good morning and welcome. It is truly a pleasure to be joining all of you this morning to celebrate really one of the most amazing treasures of the Library of Congress. The 1507 World Map by Martin Waldseemüller, known as the Birth Certificate of America, is truly one of the great masterpieces of the art of map making. The only surviving copy of the map, which names America for the first time, is part of the largest and most comprehensive collection of maps and atlases in the world, here at the Library of Congress. The library has more than 5.9 million cartographic items from the 14th century to the present time. It covers every country and subject in formats ranging from medieval manuscripts to digital data. This morning, it is my honor to launch a great website that was a successful collaboration of the Library of Congress with the Galileo Museum in Florence. This comprehensive interactive site contains more than 11 hours of video, which charts every aspect of the life of this important map and highlights the science and the culture of the times in which it was created. Digitally interactive projects like these, which bring to the web important treasures from our collection and our collective past, are changing the way scholars, educators, students, and the public interact with the library's vast collections. Waldseemüller's maps were created at a time of great revolutions, both scientific and cultural. I believe it is these revolutions and how humanists, geographers, and scientists reacted to them make the story told by this website, which is relevant for us today. The world has changed from one of medieval isolation to the more progressive ideas of the Renaissance, and our modern world came into being. In order to bring this masterpiece of the early scientific revolution to viewers around the world, the Library of Congress and the Galileo Museum have joined together to create a website which fosters not only an understanding of the past, but also hopefully helps all of us to navigate our technological and scientific future. I would like to give special appreciation to Professor Umberto Tamburi, along with Dr. Paulo, and I practiced, I have to tell you, along with Dr. Paulo Gulusi, and Dr. Filippo Camarata, Director and Vice Director of the Galileo Museum, for their support of this project. And I would also like to congratulate everyone else involved in its creation, both here at the Library of Congress's Geographic and Map Division, and also the Galileo Museum. And now it is my honor to welcome His Excellency Armando Varricchio, Ambassador of Italy to the United States.
Good morning, everybody, dear friends, ladies and gentlemen. It's always good for me to be back at this great Library of Congress, renowned for the wealth, depth, and breadth of its collection. A very warm thank you to the newly appointed Librarian of Congress, Dr. Carla Hayden. A warm welcome to her new role. To Dr. Hayden, who, by the way, managed to pronounce my name in a perfect way, I'm really puzzled by this, was responsible for protecting and disseminating the knowledge of the largest library in the world. We offer our full collaboration on the many inspiring and mutually enriching projects yet to come. A warm welcome to Professor Umberto Tombari, President of Ente Cassa di Risparmio di Firenze, which financially supported the project. To Professor Paolo Galluzzi and Professor Filippo Camerota, Director and Vice Director of the Museo Galileo. To Laura Campbell and to Ralph Ehrenberg and John Hessler of the Library of Congress. A land beyond the stars. What name could be better for this conference, bringing together the knowledge and excitement of the unknown, yet to explore? This reminds me, by the way, back in July, I attended an extraordinary event at the JPL NASA Center in Pasadena, California. On that very night, human made possible to send to Jupiter's orbit, by the way, an artifact called Juno, with a sentimental also link of Juno finally reuniting to Jupiter, where Italian scientists and physicists were a great part. So this to show that the great journey goes on. But as you are probably aware, the Library of Congress, together with the Museo Galileo di Firenze, has organized this wonderful exhibition of the Universalis Cosmographia map by Martin Walters Müller for the first time in Washington at age 500. This splendid map is widely recognized as being the first to bear the inscription of the name America over the newly discovered land just 15 years prior, the land beyond the stars, discovered on the other side of the ocean. In Vespucci's own words, those new regions which we found and explored with the fleet, we may rightly call a new world, a continent more densely peopled and abounding in animals than our Europe or Asia or Africa. And in addition, a climate milder than in any other region known to us. Well, at that time, climate had not changed yet. But Italy didn't only have a role in the naming of the New World. This Carta Marina is also referred to as the new Vespucci map, as it credits and discovery of the new continent goes to the great Florentine explorer and cartographer who believed that the new lands were not part of Asia, but rather of a fourth part of the globe, as he used to say, and different from previously identified continents. It is therefore only fitting that the city which he hailed from, Florence, has deciphered the map in its entirety. In fact, Museo Galileo, renowned for holding one of the best collections of scientific instruments in the world, has created an impressive digital tool which makes the map available to everybody, thus providing a fascinating look into what truly constitutes an immense encyclopedia of knowledge of the time. Not only does it tell us about Wethesmüller cartography. It also tells us about his life. So, our long-lasting and very productive collaboration with the library has yielded another winning project, which not only benefits those of us who are here today and who can admire firsthand these beautiful works, but the many who are not able to join us today and who will be able to enjoy this splendid work online in the future. Dr. Hayden, thank you very much.
Well, thank you, Ambassador, and thank you, Dr. Hayden. A website like this doesn't come without cost. It doesn't come without the need for support. And also, the purchase of the map itself, its encasement, doesn't come without support. So we have to thank all of those external donors who helped us both develop the website and purchase the map and its preservation here at the Library of Congress. And with that, it is my great pleasure to introduce Professor Umberto Tumbari, from Florence, who is primarily responsible for the actual funding of the website itself. Professor Tumbari?
So thank you to everyone. Professor Hayden, Your Excellency, my dear colleagues, I am deeply honored to be here with you today in this hallowed setting, the Library of Congress, that is widely recognized to be the largest library in the world, with millions of books, recordings, photographs, newspapers, and maps gathered in its collection, a universal forum of erudition that preserves and provides access to a rich, diverse, and enduring source of knowledge ready to inform, inspire, and engage us all in our intellectual and creative endeavors. I cannot help but feel that there is an especially close bond between this institution and our foundation, Florence Foundation, which has been supporting and promoting culture in Florence and in Tuscany for almost 200 years, while constantly tailoring the way it does so to changing times. A perfect example of how it does that is the presentation of this website. With its huge impact, a website we have funded and produced with the magnificent team from the Museo Galileo in Florence, and in close cooperation with the Library of Congress, which I would once again thank for its amenability and its hospitality. The Wethesmüller map is a compendium of exceptional knowledge, which, then as now, underscores the close tie binding Florence and America under the aegis of a traveler as extraordinary as Amerigo Vespucci. If we are here today to maximize the potential and deepen our knowledge of this monument to global cartography, sharing in the project for the website that Professor Galluzzi will be illustrating to you shortly, we owe it to the ethos of conservation, of which Florence is one of the world's unquestioned capitals. That is why we are intervening in support of the Opificio delle Pietre Dure di Firenze, Florence's illustrious, historic, and indeed world-famous school of restoration that is in danger of losing valuable skills. But we need to look ahead. And I firmly believe that it is our duty to develop new ways of devising different takes on the past in a contemporary vein. These are the goals to which my foundation, pro tempore, my foundation, of course, is strongly committed today, and to this end we have embarked on a strategic project to launch a service model formulated to foster a new renaissance, capable of optimizing Florence's splendid humanistic tradition in a new, more modern and more dynamic light. A new renaissance, I said, a new renaissance that should matter to everyone. In this connection, we are currently busy identifying a selection of programs that use the ecosystem of beauty as their source of inspiration for projects and schemes designed to promote cultural innovation and social development, and broadly open to partnership and to the launch of systematic interaction with those like you and like us who are sensitive to such issues. So what I'm talking about here is a new direction. A concrete example of this is the cooperation set in motion between our Museo Galileo and the Library of Congress, a project that has been given a genuinely enthusiastic reception by Ambassador Armando Varricchio, to whom I would like to express my heartfelt gratitude. Thank you.
Well, now it's time to actually look at the website. The website was, in fact, launched officially this morning, so it is available online. But for a preview, before we actually show it live, I'm going to give you Professor and Director of the Galileo Museum, a great Galileo scholar in his own right, Dr. Paolo Galluzzi.
Thank you, John, and thank you to the institution that is hosting this event and has offered such a cooperation in making possible this dream. There are many reasons why the Museo Galileo has devoted so much energy designing and producing an exhaustive website on Waldseemüller Cosmographia Universalis. The first reason is that this document pays tribute to the city which is home to the Museo Galileo. I obviously refer to the Florentine Amerigo Vespucci, whom Waldseemüller credited as being the first to realize that the lands beyond the Atlantic that he had reached were not the western coast of India, but a new continent, the fourth part of the world, named America in Amerigo's honor. The Florence in which Amerigo was born and raised had no seafront, nor did it have fleets capable of crossing the vast ocean expanses. Yet in the 14th and 15th centuries, Florence was a highly advanced center for geographic studies and research. Francisco Petrarca, Giovanni Boccaccio, Agnolo Poliziano, Paolo dal Pozzo Toscanelli, who was not only a great astrologer, but also a reference for Brunelleschi and inspired Christophorus Columbus. All these eminent Tuscans took an interest in the region of the earth, their cartographic representation, as well in their inhabitants. These pursuits were a distinctive feature of a humanist movement of which Florence was the dynamic hub. The very last years of the 14th century witnessed the arrival in Florence of the Greek manuscript of Ptolemy's Geography, a text unknown in medieval Europe. The event triggered the revival of interest in geography throughout Europe. Ptolemy's text, announced by maps of the known world, was copied in countless manuscripts, often richly illuminated. It was translated into Latin and the vernacular, and ultimately disseminated through printed versions. His return to the West of this text set in motion a process that lasted throughout the entire humanist period, a process characterized not only by sophisticated philological interpretations and intense curiosity about distant lands and their peoples, but also by the quest for the most effective solutions for faithfully representing the known world on vellum or paper. The second reason that led us to take up this challenge concerns information technology. Waldseemüller chart offered a fantastic opportunity to demonstrate the exceptional contribution that the intelligent use of IT can make in showcasing the historical heritage and defining new publication formats that fully exploit the web's unheard potential. During the last 3 decades, the Museo Galileo in Florence has been in the forefront of this area of experimentation and research, taking advantage of 3 fundamental assets: a wealth of documentary resources, including a large research library and iconographic archive, the presence of highly qualified scholars in the history of science and technology, and the availability of an in-house multimedia department endowed with the human resources, skills, and technical instruments necessary for digital production of the highest quality. We have, over the years, developed other projects aimed at conceiving and testing innovative digital library models. Let me just mention one among the many examples which you can explore on the Museum Galileo website. I refer to the recently published Galileoteca, which perfectly mirrors our quest for the best solution to organize, publish, and share on the web historical documents. The Galileoteca is a corpus of closely integrated archives. You see our 9 archives, each one of the hexagon is one archive, offering fast and easy access to the text, manuscripts, biographical and bibliographical records, chronology, images, and all the information needed to conduct in-depth research on Galileo and his work. Just make a browsing of the 9 archives, a huge amount of information, all linked transversally and vertically, and is a fantastic research environment available for scholars wherever they have a web connection. The same programmatic vision inspired the website devoted to Waldseemüller map. We have designed it as a repository incorporating visual documents, printed and manuscript sources, videos illustrating the functioning of nautical instruments and the method for producing cartographic projections, 3-dimensional simulations, diagrams, interactive timelines, slideshows providing context, and all the resources necessary for an easier understanding of the massive amount of information contained in this exceptional cartographic monument. Information that would be impossible to decode with traditional publishing methods. The complex IT architecture that we have built is not an end in itself. It can be reused for other projects. We are planning to apply it to showcase with similar browsing tools and facilities another great cartographic monument of the early modern age, Fra Mauro's world map, just over half a century before Waldseemüller map. Similarly, the Galileoteca structure forms the skeleton on which we are modeling a new and even more challenging project, the Leonardoteca, a digital environment to facilitate easy online access and study of Leonardo's manuscripts. Truly a labyrinth, if ever there was one. Today's event is cause for great satisfaction for many reasons. As a head of an institution that endeavors to keep up with the times, to explore innovative research paths and test new methods for organizing and disseminating knowledge in the global universe of the web, I am particularly happy about the fruitful cooperation that we have established with so prestigious an institution as the Library of Congress. I trust that new opportunities will soon arise for us to join forces on other ambitious projects. It is no less a satisfaction for me to witness the completion of a project that started with an idea that flashed through my mind a few years ago when I was first able to admire Waldseemüller original map at the Library of Congress. How could one best explain the infinite messages contained in this cartographic monument, illustrate the theoretical and practical knowledge that made its production possible, and reconstruct the context in which the map was made? It immediately came up. It immediately occurred to me that the most effective method would be to transform the map into a vast digital repository, accessible on the web, accompanied by the technical and intellectual instruments needed to explore the map and help the public to understand its historical importance and uniqueness. The proposal to produce an advanced web-based system for exploring and contextualizing the map was greeted with enthusiasm by our colleagues at the library, especially Laura Campbell, then Associate Librarian for Strategic Initiatives, and the Librarian of Congress, James Billington. The expert and heartfelt participation of Ralph Ehrenberg and John Hessler and the entire Geography and Map Division of the Library of Congress proved essential to the preparation of the website. I thank His Excellency, the Ambassador of Italy to the United States, who offered his generous and decisive support to this project and to its presentation in Washington, D.C., as well as his expert staff, among whom I would like to mention Professor Renato Miracco. This ambitious enterprise would have been impossible without the support, collaboration, and unstinting encouragement of a time-honored Florentine institution, Ente Cassa di Risparmio di Firenze Foundation, committed to sponsoring initiatives such as these, which convey the image of Florence and Tuscany across the world. The Florentine Foundation has also promoted the publication of an elegant volume accompanied by a flash drive which illustrates the scope of this project. I express my appreciation and gratitude to the Foundation's chairman, Professor Umberto Tombari. Let me conclude emphasizing that a large share of the merit of the project goes to its de facto author, Filippo Camerota, Deputy Director of the Museo Galileo. Filippo drafted most of the materials and coordinated the preparation of the website, entirely produced by our museum's multimedia department. He will illustrate for you the structure and content of this resource, available as for today in Italian and English on the website of the Museo Galileo. Thank you.
Well, now we will actually dig into the website a bit. And it is my great pleasure to introduce the primary drafter of a lot of the content as you will see it, the Associate Director of the Galileo Museum, Dr. Filippo Camerota.
Good morning. I would like to introduce myself as the filmmaker of this project, just because this was the way in which I worked with the graphic designers. As you heard, the website is online. It's already online since early in the morning. So if you have a tablet here, you can follow me in this brief navigation through the new lens of digital library. The website, in fact, is we conceived that as a model for a new concept of the digital library. And it's a tool, an educational tool and a research tool addressed to a large public, possibly to any kind of user, from scholars, from students to scholars. Unfortunately, we cannot see all the movies because it would take too much time, and we don't have that time. So, but we will see some very interesting and representative samples. So I think it's the case to go directly to the introduction here on the upper part of the homepage.
The world map designed by the German cartographer Martin Waldseemüller grew out of an ambitious project to present the latest geographic knowledge compiled from recent Spanish and Portuguese ocean voyages. The map was drawn in 1507 using data gathered by Amerigo Vespucci during his expeditions to the New World from 1497 to 1504. Waldseemüller christened the new land America in honor of the Florentine navigator, who was the first to recognize that the coasts he had explored belonged to a new continent. By portraying the New World as a separate continent, Waldseemüller's map constituted a huge leap forward in geographic knowledge, marking the end of the traditional division of the Earth into three parts. The map in the Library of Congress is the only known surviving copy of a printing that, according to the author, totaled 1,000 copies. Long thought lost, the map was rediscovered in 1901 by the Jesuit historian and cartographer Josef Fischer in the library of the castle belonging to the family of Prince Johannes Waldburg-Wolfegg in Baden-Württemberg, Germany. The map, made up of 12 sheets, measures 138 by 238 centimeters, or 4.5 feet by 8 feet. Purchased by the Library of Congress in 2003, it is now on display in the Great Hall of the Thomas Jefferson Building. This website was designed to allow a wider public to appreciate the wealth of information contained in the map and to decipher its structure and graphic symbols. The website aims to serve as an experimental model for a new digital library concept.
As you can see, the 12 plates composing the map are displayed on the on the homepage as gateways to 12 exploration themes, and the general index is available here from the through the sitemap, where we can see the 12 chapters with subdivided into approximately 200 sections. With 41 comprising 41 videos and 25 3D animations. And the topics are arranged according to an ideal sequence, but of course users can move freely in the website, through the website, just choosing the theme of personal interest. Let's see, for example, from here, the humanist interest in cartography.
The map makers engaged in universal cartography in the 15th century were often learned humanists who provided subtle interpretations of highly diverse sources, ranging from classical Greek and Latin authors to written and oral accounts by merchants, travelers, diplomats, and ship pilots, as well as graphic sources.
This is just a short sample of the kind of movies you will find in the website, and from here, from here you can read the text of the movie, which is useful sometimes just to learn better some names or information. Here, this is the historical context. So the first chapter is devoted to the humanist interest in cartography and geography, and there are several slideshows with the introduction of the two protagonists of this history, Martin Waldseemüller and Matthias Ringmann. Matthias Ringmann is always a little bit in the shadow, but in fact he was the humanist behind the cartography, and he played a very important role, possibly. He was the one who invented the name America. Here we have a timeline where the fundamental steps in the production of the maps of Waldseemüller are shown since the foundation of the Gymnasium Vosagensis in 1419 up to the printing of the Carta Marina in 1516. Let's go to the second chapter, which is an interactive exploration of the map with a terrific enlargement of the details. We can see, for example, here a very interesting detail, one of the most curious details of the map. This is the wasp, which is an important element of the coat of arms of the Vespucci family, and in fact is depicted next to the portrait of Vespucci. Vespucci as a cosmographer of the New World, in front of Ptolemy as the cosmography of the the ancient world. From here we can see separately the 12 sheets, where we find some details which are not visible in the mounted map, like this note, handwritten note by Johann Schöner, who was the owner of the map. Now it's still out of focus, I think, but it takes a little bit time. And there is the possibility from here to rotate the map in order to read the names which are written in a vertical or diagonal line. And there are, of course, presentation of the two protagonists here, the two cosmographers, and we can see the coordinates traced on the map, and that traced by Schöner in order to design his own maps from this map of Waldseemüller. One of the most interesting element of this exploration is the visualization of the 26 regional maps by Ptolemy, which here we can see through the maps depicted by Henricus Martellus Germanus for an edition of the cosmography, which was probably one of the most important sources for Waldseemüller. For example, here we can find a name, a toponym here, with the same corrupted Latin word. I don't know if you can read, columne with a P instead of columne, and this is the word used and written by Waldseemüller too. So possibly this was one, the main source for him. And of course, all the maps are visible here. And we can read all the cartouches of the map. There are 159 cartouches, and we give for them the Latin transcription and the Italian, and in this case, English translation. These islands were discovered by Columbus, Genoese admiral acting on the orders of the King of Castile. So it's full of information. It's actually an encyclopedia of geographical discovery. And we have a lot of also toponyms, kingdoms and provinces, 185 names, or 100 names, toponyms for the New World, which are compared with the same names found in the maps, coeval maps, which is useful just to learn how a name was developed and invented and transcribed by the several cartographers. Here you can see the mountains with their name, rivers, and so on. So this is a way to read what is normally unreadable in the map. Chapter 3 is a visual translation of the book printed joined to the map in 1507, the Cosmographia Introductio. Here we have the chapters of the book and the geometric and cosmographic definitions given by Waldseemüller, but they are translated in images, just to allow everybody to understand what is going there. This is the definition of the sphere, which is made not just as a simple surface, but as a surface made of many, many points equidistant from the center. But here, down here, you can see, you can read the definition given by Waldseemüller. From here, you can go to the Latin text, which is in the digital library, which opened exactly in the page where the definition of the sphere is given. You can read, of course, the entire book just in this way, which is always very useful because you have an idea of the... You see, there are no images in these books, just a written text. So I think in this case, the translation of text in images is quite useful and also very direct in translating, in giving information about cosmography. Not always it's easy to understand what is equator, zodiac, colures, and so on. The images are given in 3 dimensions, but sometimes you can compare an orthographic projection with a perspective projections just to understand what is the local horizon, for example. In orthographic projection, it's just a line tangent to the Earth, but you can understand that actually is a disk, it's a circle, which can be visualized in the middle of an armillary sphere. The armillary sphere for us is the most common instrument which gives information about the structure of the sky. Cosmography, of course, was important. Cosmography as the science of sky, also to understand what is on the Earth. Going from the sky to the Earth, this is the path that Waldseemüller is following in this book. And here you can finally have the information about the several places in the world. The appendix gives still a visual representation of the quadrant, which is drawn in the book, but it's not actually clear in the xylography. And here we have the end of the book, which is the description of the 4 voyages by Amerigo Vespucci, which here are visualized with 4 images. These images can be seen as a movie in section 8, for example, devoted to the New World, where we have, just to have an example, the 3rd voyage of Vespucci.
Vespucci's 3rd voyage remains a subject of historical controversy to this day. Scholars have voiced serious doubts that it ever occurred. For Ringman and Waldseemüller, however, who published Vespucci's letter to Pier Soderini on his 4 navigations in the appendix to the Cosmographia Introdutio of 1507, the voyage did take place, and it was one of the most important. In his letter, Vespucci writes that he outfitted a fleet of 3 ships and sailed from Lisbon on May 10th or 13th, 1501. His 3rd voyage was conducted at the request of King Manuel of Portugal, who was surely motivated by the news of Amerigo's discovery of lands east of the Tordesillas meridian. The expedition reportedly lasted 16 months.
So go back to section 4, which is a collection of maps produced before Waldseemüller and after Waldseemüller. This is useful just to learn which kind of sources Waldseemüller had at his disposal in order to build, design his map, and which kind of fortune we can see, for example, here a map of Martellus, and of course even here we have a very interesting enlargement of the map, and we can still rotate the map, which is useful when names, as I said, are written in not in a horizontal line. And after Waldseemüller, we have a lot of maps which reproduce the shape of the map, but also the name America. This is Petrus Appianos. This was the first map before the discovering of that of Waldseemüller, who was known as the one naming America. But there are many of them like this, which is one of the most curious maps of the Renaissance, with the map of Waldseemüller put in the face of a fool. But here, interestingly, the name America is written in the north part of the continent, so it shifted a little bit upper. And just because in this age they understood that this also was a separate continent and not a part of Asia as Columbus believed. Other contemporary maps means different kind of projections. The interesting thing with Waldseemüller is that he was trying, and he did, to represent the entire surface of the world, that is 360 degrees, using a projection method that was not described by Ptolemy, because Ptolemy represented only 180 degrees, so a half of the surface of the Earth. And so several cartographers in the same age were looking for projection methods capable to represent in a flat surface the entire Earth. This is the case when, for example, it's useful to have this tool here because we have a lot of names written in different lines. And the globes, of course, because after the one famous of Martin Behaim, we find which was painted on a globe because the printing was not yet the technique for transmitting knowledge. And with Waldseemüller, we found for the first time the way to represent a sphere through the gores in this way, and we have all the different solutions, or at least different images developed by Waldseemüller in the representation of this globe. Coming up to the Hunt-Lennox globe, which is the first representing, perhaps built in Florence in 1510, representing America, or at least the mundus novus, in the way Waldseemüller represented it. From section 5 to section 8, we enter a brief history of cartography. So we have the ancient world with the story of Ptolemy before Ptolemy in the transmission of geography with the Cosmographia. We have the world discovered and described by Marco Polo, Niccolò de Conti, and other travelers in the Middle Ages. We have the route to Indies, so the Turkish blockade of Mediterranean and the project of the Portuguese. These are all slide shows. The Portuguese to circumnavigate Africa. And then the New World, where we found an introduction to Paolo dal Pozzo Toscanelli. His letter was fundamental for the project developed by Columbus. We have the 4 voyages by Christophorus Columbus, the 4 voyages, as I showed before, of Vespucci, and a slideshow on the political division of the world with the line of Tordesillas. But I want to stop a little bit on section 9 because I think this is the most interesting, the most innovative in terms of educational and research activities. We have here the problem of how to represent the spherical surface of the Earth on a flat surface. So this is a cartographic projection. Ptolemy's projections and Waldseemüller projections and other cartographers' projections are represented here through 3D animations, which gives always the concept related to the idea of that projections and the drawing method, how to draw it. Ptolemy described how to draw his projection in the Geographia, but reading the text is quite difficult to follow him. And these animations, I think, give a good idea. Let's see, in this case, only the second projection of Ptolemy, because this is the base for Waldseemüller's map.
Ptolemy's second cartographic method attempts to reproduce an image of the oikoumene, that is the inhabited world, more closely resembling that of the terrestrial globe, giving the representation a spherical appearance that is almost totally lacking in the first method. While visually pleasing, this concession adds nothing as regards the measurability of geographic coordinates, a requirement already fully satisfied by the first cartographic method. To obtain the desired effect, Ptolemy imagines that he is looking at the globe from a point located exactly at the center of the oikoumene, not only with respect to the longitudinal amplitude as in the first method, but also with respect to the latitudinal amplitude. The viewpoint thus shifts from the zenith of the Rhodes parallel to that of the parallel passing through Syene, modern Aswan, situated precisely on the Tropic of Cancer at latitude 23 degrees and 30 minutes north. Next, Ptolemy imagines a representational plane tangent to the point of intersection between the central meridian and the Syene parallel, and he proceeds to transfer the geographic coordinates onto it. As a result, the largest circle tangent to the representational plane and the orthogonal to the central meridian, in other words, the elliptic circle, appears as a horizontal straight line. Such a circle does indeed lie on a plane passing through the observer's eye. For the same optical reasons, the central meridian will be seen as a vertical straight line. Because he needs to ensure that distances are measurable, Ptolemy marks the equal intervals of 5 degrees on the horizontal line that define the map's longitudinal amplitude to the right and the left of the central meridian. With the same intervals, he then marks the latitudes of the main parallel circles on the central axis. These are the equator, the so-called anti-Meroe parallel, and the Thule parallel. As the equator intersects the elliptic circle at 90 degrees from the central axis, it will be shown on the plane as an arc intersecting the horizontal line at either end. The other circles will appear as arcs concentric to the first. Their widths are defined by the measurement of the 5-degree intervals, which varies with latitude. The center of the curvature of the parallel arcs appears on the central axis after tracing the chord of the equatorial semi-arc and the straight line orthogonal to the center of the chord. By joining the ends of the parallel arcs with two curved lines representing the 0-degree and 180-degree meridians, Ptolemy obtains the space containing the map of the oikumene. As in Ptolemy's first method, the map is designed as a peel transferred from the globe to the flat surface. Ptolemy's second cartographic method attempts to reproduce.
And now we see how to draw it.
To draw the map of the oikumene, that is, the inhabited world, with the second cartographic method, Ptolemy begins by setting the boundaries of the area to be drawn, tracing a rectangle whose width is equal to twice its height. The shorter side is divided into 90 parts corresponding to the degrees of 1/4 of the Earth's meridian. Starting from the bottom, he then plots on the central axis the points corresponding to the parallels passing through Antimeroe, the equator, Syene, and Thule. Next, he traces a horizontal line passing through the point corresponding to Syene. The line obtained represents the image of the oblique circle of the ecliptic as it appears to the viewer. The ecliptic looks like a straight line because it lies on a plane that is level with the observer's eye. The segment connecting the equatorial point and the end of the horizontal line is the chord of the arc that, in this rendering, denotes the circle of the equator. The perpendicular drawn from the center of the chord marks the center of curvature of the equatorial arc on the central axis. Having found the center of this arc, Ptolemy then draws the concentric arcs representing the parallels passing through Thule, Syene, and Antimeroe. Taking 5 units as the measurement of the interval between meridians on the equator, Ptolemy divides the equatorial arc into 36 equal parts, in other words, 180 units. By means of a mathematical calculation, or using the more practical solution of a terrestrial globe, he then measures the value of the same intervals on the Thule, Syene, and Antimeroe parallels. To draw the meridians, he constructs a series of arcs passing through 3 points chosen on the Thule, Syene, and Antimeroe parallels. The outermost meridians have a radius of curvature easily measured with a compass. By contrast, the innermost meridians approaching the straight line have a very large radius, which the cartographer was obliged to measure with a string. Unlike the parallels, which are concentric arcs, the meridians are arcs whose curvature increases from the center outward. The central meridian, which lies on the plane level with the observer's eye, appears to be a straight line. Ptolemy interrupts his explanation of the cartographic method at this point, but the tables illustrating the 15th century manuscripts of the geography clearly show that the next step consisted in drawing the parallels every 5 degrees of latitude or at variable latitudes. This was the method used to fill out the cartographic grid that served as a guide for drawing coastlines, cities, mountain ranges, rivers, and lakes. Colors, inscriptions, depictions of winds, and ornamental motifs completed the pictorial and cartographic representation of the map of the oikumene.
And now we come to our map, Waldseemüller's map.
Ptolemy's map represented only a portion of the terrestrial globe, the oikumene. that is, the known inhabited world. In contrast, Waldseemüller's map shows the entire surface of the Earth except the southern cap below the 44th parallel. The Ptolemaic oikomene is depicted at the center of the map using Ptolemy's second cartographic method, which supplies the geometric elements needed to expand the drawing. From a geometric standpoint, Waldseemüller's map is indeed an extension of Ptolemy's second cartographic method. Beyond the boundaries of the ancient world lie the remotest regions of Asia described by Marco Polo and the New World described by Amerigo Vespucci. Ptolemy's world and Vespucci's world are illustrated separately in the two small hemispheres drawn at the top of the sheet next to the portraits of the two cosmographers. The Ptolemaic hemisphere coincides with the central part of the map, whereas Vespucci's hemisphere is depicted in two halves, one on the left, the other on the right. The top piece illustrates the lands to the north of the parallel passing through Thule up to the Arctic Pole. The map's overall aspect closely resembles a solution developed in the same period by Leonardo da Vinci. Unlike Ptolemy's,
Differently from Ptolemy's method of drawing a map, which is described in the geography, for Waldseemüller we don't have any information about the procedure he used, so this is just an interpretation based on the map.
maps, Waldseemüller's map showed the entire surface of the globe. To draw it, Waldseemüller developed a geometric extension of Ptolemy's second cartographic method. In doing so, he adopted the approach proposed a few years earlier by Henricus Martellus. The geometric expansion was suggested by Ptolemy's map itself, on which the extension of the meridian arcs indicated a potential configuration for the cartographic representation north and south of the boundaries of the oikumene, that is, the inhabited world. Having presumably followed this indication, Waldseemüller marked on the central axis the latitudes of the equator, the North Pole, the Arctic polar circle, and the last parallel chosen as the southern boundary, 40 degrees below the equator. He then set a center of curvature 90 units from the North Pole, slightly beyond the center chosen by Ptolemy, and drew the main parallel arcs. To plot the variable 10-degree intervals on the parallels, he chose the gore shapes used to build the globe in solid form. The German cartographer then took a reduction compass and set it to a ratio of 1 to 8, which is the size ratio of the gores to the map. He measured the intervals on the equator, on the polar circle, and on the last southern parallel, plotting them on the corresponding arcs on the map. Next, he drew two intermediate parallels, one passing through the city of Syene, 23 degrees and 30 minutes above the equator, and one situated at 20 degrees below the equator. He subdivided these parallels, like the others, into 10-degree intervals. He could now trace the meridian arcs above and below the equator, constructing them as curves intersecting 3 points. As in Ptolemy's first cartographic method, each arc was split at the equator. To build the meridian arcs north of the Arctic polar circle, Waldseemüller seems to have chosen a laborious geometric construction. He began by tracing the chord of the outermost meridian arc, making it end a short distance above the North Pole, so as to obtain a horizontal line. On this line, he drew an equilateral triangle positioned in such a way that its vertex serves as the center of curvature of the meridian arc. He then traced the chord of the meridian arc closest to the central axis and placed the center of curvature at the intersection between the line perpendicular to the chord and the horizontal line passing through the first center of curvature. The horizontal line thus became the location of the centers of curvature of all the other meridian arcs. He then drew the chords of all the meridian arcs, marked the center of each chord on an arc passing through the center of the first two chords, traced the respective perpendicular lines, and marked the centers of curvature of the meridian arcs on the horizontal line. The final step in the geometric construction of the world map consisted in drawing the meridian arcs north of the Arctic polar circle. On this cartographic grid, Waldseemüller drew the profiles of lands, perhaps starting with Ptolemy's Oikumene, which the German cartographer reproduced with no geographic updates. He then drew the lands of the Far East up to modern-day Japan and the southern reaches of Africa, circumnavigated by the Portuguese. Lastly, he drew the coasts of the New World using information from Spanish and Portuguese map makers. He completed the drawing by marking cities, rivers, mountains, and winds, and by inserting a wealth of text information, all enclosed in an exquisite ornamental frame. The printing process was no less complex given the size of the map. Waldseemüller divided the sheet into 12 parts, adopting a simple geometric construction using diagonals or dividing the two sides of the image in 3 and in 4. He cut the entire sheet into 12 smaller sheets and engraved a separate wood block for each. To transfer the image to the block, he presumably used the dusting method, perforating the entire drawing with a punch. He then placed the sheet on the wood block facing down and transferred the drawing by means of a pad coated with colored powder so as to leave the trace of the image in reverse on the wood. Now, an engraver set to work removing the wood from all the parts of the drawing that were to remain white in the final print. When the carving was complete, the wood block was inked and pressed against a sheet of printing paper. And so the 12 prints were assembled to form the world map that gave its name to America.
It was an immense work, no doubt. And we can see also the globe, because this is the first time we find a globe drawn in this way with the gores.
The meridians and parallels that by convention define the geographic coordinates of places on the surfaces of the Earth can be grouped together into 12 shapes called gores, each covering 30 degrees in longitude. If we imagine that we could peel the Earth as we would an orange, we can lay the gores flat on a plane surface, forming a map that is discontinuous but free of distortions. This method made it possible to draw, print, and construct a terrestrial globe by pasting the 12 gores onto the solid surface of a sphere. To draw the gores that compose the terrestrial globe, the mapmaker starts by drawing the line of the equator, on which all the degrees of longitude are marked at equal intervals. 36 intervals of 10 degrees each form the entire circumference of the Earth. By convention, each gore is 30 degrees wide and is bounded by 2 arcs of a circle with a radius equal to 270 degrees. Inside each gore, the mapmaker draws 2 other arcs passing through the poles of the intermediate meridians. By dividing each arc into equal parts representing intervals of 10 degrees, the map maker obtains a series of points that, once connected horizontally, make it possible to draw all the parallels. By transferring the geographic coordinates of places onto this cartographic grid, the map maker can draw the Earth's entire surface on a plane, which will assume a spherical shape only after attaching the gores to the surface of a globe.
Here there is a section which answer, I think, to one of the questions made yesterday about the extension of the world. We have a comparison between the world of Ptolemy and the actual world. Actually, the world of Ptolemy was smaller than the real one. We can see that the world of Ptolemy actually covered only 120 degrees on the surface of the Earth. And we can see the Framaurus world, which is still based on the dimensions of the Ptolemy's world, but it's a little bit bigger because there is the part of Asia described by Marco Polo, and Columbus' world, still same size, with the missing part, which was that the one which would have made a difference if he would have known that there was such a long distance between Portugal or the Fortunate Islands and Japan. Actually, this was the distance estimated by Toscanelli and Colombo, and this is the real distance. And then Vespucci's world, which is a little bit bigger just because it includes the new lands discovered on the ocean, Atlantic Ocean, but you can see here Japan is very close to the North American, actually is in the same place of California. And section 10 is devoted to the ocean, and then here we find the Carta Marina, which we can explore more or less in the same way we did with the world map, enlarging it as we wish. The resolution is very big, thanks to the files produced by the Library of Congress. And even here we have the concept and the drawing method of the Mappa Marina, the Carta Marina.
The sea chart is a transformation of the spherical surface of the terrestrial globe onto a plane surface that we can imagine as being tangent to the point of intersection between the meridian and the equator. The transformation is performed by transferring the meridians and parallels onto a cylinder that surrounds the terrestrial globe and is then developed onto a plane surface. After the transformation, the meridians and parallels form an orthogonal grid divided into regular intervals of equal size. However, while the length of the meridians remains unchanged with respect to their length measured on the globe, the length of the parallels increases as one moves from the equator to the poles. The advantage of this cartographic transformation is that while altering the measurement of longitude, it preserves the orthogonal intersections between meridians and parallels as on the terrestrial globe. In consequence, any given oblique line showing a direction of the windrows will always meet the meridians and parallels at the same angle, exactly as it does on the terrestrial globe. This is clearly an advantage for plotting navigation routes. To prepare the sea chart, the cartographer begins by drawing a rectangle twice as wide as high. He then plots the two central axes and divides them into equal intervals, 18 on the vertical axis and 36 on the horizontal. Next, he draws the entire grid of meridians and parallels. Waldseemüller confined his attention to the section of the grid extending 240 degrees in longitude between latitude 70 degrees north and latitude 50 degrees south. The grid is only a construction diagram and so does not appear on the actual map. Waldseemüller then traced a circle with a radius equal to the vertical.
I stop it here because the time is gone, and just to give you some more information, we have a section on the sky too, so astronomical instruments for navigations, and there are a lot of slideshows here and animations giving the instructions of how to use instruments for navigating. And then the last chapter is devoted to the digital library with a list of books related to the production of the maps of Malzemüller, of course, and maps which are more or less the same maps we have seen in section 4. And I think this is all, and the website is online, so you can continue by yourself. Thank you for your attention.
So you can see there's a lot of content here. It would take about, 14 hours to actually go through the entire website if you were to watch everything. Obviously, there was a lot of time and a lot of argument about how to look at these things as the website was developed, but you can see that it is now out there for the world. I would invite Filippo and Paolo to come up if people have any questions. We can answer them.
That is spectacular.
Thanks.
When you began the project, did you envision it as vast as it ended up?
Not at all, not at all. This was something that was developed in the time. This is why I said before that I consider myself as a filmmaker. This is not my profession, but in this case, this was the change in my way to work that it happened. I started as a scholar, just giving text to the graphic designers, and then I realized that in order to make these kind of things, I had to be there with the graphic designers and work with them every day. And fortunately, we have a multimedia laboratory in our museum, in our institution, and it's easier to work with people who are accustomed to understand these kind of topics. But, of course, it was not visible before.
It hasn't stopped growing either. There's going to be additions to it as the page turner for the actual Sammelband, and now we're talking about the Carta Marina, and so it's not, it's an obsession that will not end.
And it's very important also to consider that after this first huge step, you should imagine that this becomes a research environment, a collective research environment, where we will make space for interaction from users, and eventually also having a site where they can publish their comments, being registered before, of course, and so making grow this archive and keeping it updated thanks to the users' contribution. That will not be all kids, will be scholars who will use this and will have something to say, and would be nice to have that embedded into the website.
One additional thing I think I want to show, just since the website is back up here, and I think one of the most interesting things about, whoops, that's not what I want. One of the things that people always want to know about is astronomical instruments and navigation instruments and how they work. So for instance, there are videos in here which basically show how all the different navigational instruments work. All 3D animations, and basically the nocturnal astrolabe, the quadrant, the nautical astrolabe, all of this stuff is animated. And I think it's one of the most important parts of outside of the construction of the Waldseemüller map, I think it's one of the most important additions, because this is always a question many, many people ask. So I just wanted to show that because we didn't get to it. So.
Couple of years.
Sorry, just leave it on.
Slightly less than 3 years, I would say. Huh? Do you think so, Filippo asked?
It must be used resource could apply any other topic in the museum or in the library.
Absolutely.
Is there any intention to do that? Otherwise, all the resources.
Yeah, I think this is a way, the right way of conceiving what we call general digital library. It is too often in a very passive and limited way. I mean, digital library means creating an environment where not only books, manuscripts, but images, stories told by contemporary graphic computers, documents, objects are all linked together, as have been linked through the development of history, but have been separated in different institutions for preservation reasons, basically. Now you have this chance to forgetting the preservation concerns and linking again data that are linked intrinsically among them. So this is, as you suggested, is a model. You can add these to as many maps as you want, but not only maps. I showed before the Galileoteca, which is a way of creating a research environment with all the material that scholars use when they study on Galileo. We are doing the same with the Leonardoteca. And I think it's the way in which the revolution, huge revolution, which has happened with the digital technology, and there's nothing I mean, Gutenberg Galaxy was nothing compared to what has happened now, has to be exploited. And so this is the reason why you need models. You need to try to find ways of organizing documents and knowledge in a different way.
Yeah, the last square on this is called the Digital Library, and in that are all of the books and all of the maps that were used in a more traditional form. So you can click on one of the books and a page turner comes up. So all the sort of traditional sources are in that last section too. So for scholars who want to actually look through every one of these books, every one of the books that went into this website and every one of the maps is fully digitized in high resolution in that back end. But it really is a model.
John, I see that by the icon, I believe, on the top right, that the site is also available in Italian language. Are there any plans to add any other languages like Spanish, French, etc.?
Do you feel like translating?
No. I'm just looking at the wider population that could have a great interest in this.
Yeah.
Certainly important would be at least a Spanish third language. At the moment, our energy is exhausted and also the financial resources are exhausted, and we have to find partners. We have absolutely open. In the book that has been published and that you will have soon copies available, we have provided also Portuguese and Spanish translations because we are perfectly aware that these are two words to which we have to talk to.
I'm sort of interested in the fact that you have used a map to have a multidisciplinary explanation of an awful lot of things that have to do with maps, but it becomes the center. The technology you have could be used to achieve a dream that I have, which is to see whether we can't take the Mediterranean basin, take maps and draw 25-year histograms building up from what happened from Ur right on up to what happened to the Second World War, using the map as the focus to let people probe more deeply into any subject of historical interest in any part of that basin. It is our cradle for most of civilization. But the technology that you have, if it's not continued to be used, I hope you don't lose it. I hope somebody picks it up and sort of takes it beyond where you have to do things along the idea of that. Of course, it takes money, but it's a wonderful way to just sort of lay out a broad broad range of disciplines.
As you know, technology changes very quickly, so we have to follow this path, and then, yeah, all right.
The thing about this is what you see here is what can be achieved when you place scholars next to an in-house, multimedia, really talented but very small development team, and you lock them in a room, and you basically bang ideas around and around and around and around. And that's the model here. And the Galileo Museum is so perfectly suited to this kind of work. It is really a model for how to do the digital humanities. There is no question about it. When you take a thing like this, you're not just throwing this masterpiece of cartography up there and saying, well, here's a masterpiece of cartography. We're doing very much what, say, Joachim Gaspar called for in his talk yesterday, that you can't just look at this as just a map, as some geographical thing. There is so much culture and science embedded in this document, and it is a way to teach the history of science through images, and it is the modern digital humanities at its absolute best. And so that's really well, at least that's what I think it is. I'm, of course, biased, but...
Well, I think that you touched upon a very important point, which is the cohabitation of developers of informatic programs and software and scholars and people who have idea what should be communicated. This is very rare still in our world. And as I stress in my small initially remarks, is one of the privileges of this institution. We have arrived at the point in which 1/3 of our budget goes in IT, and 1/3 of our personnel is IT person. And this is a challenge that we have, taken a risk, but I think is going to pay.
And those animations that you saw, like the Waldseemüller drawing animations, those speculative tools that you can use to show people how this map might have been drawn. We could stand up here and give papers all day about, with little PowerPoint presentations about how that was drawn, but it doesn't show you it the way it shows you here. I mean, you get a real sense of the complexity and the tools that were necessary to make this map. I mean, you really walk away. And like I said, there is 14 hours. I don't know how long it would take you to look through this entire thing. I haven't, it's weeks. There's so much embedded information in here. But any other questions? Or Laura?
Yes.
By the way, Laura Campbell, who is sitting in the front row or second row here, was really, when she was the head of OSI, which is the Office of Strategic Initiatives, she was really responsible for putting the Galileo Museum in touch with the Geography and Map Division, and really she deserves credit, as she says, for, she doesn't want to take much credit, but for opening the door, so.
Thank you very much. Congratulations, you have achieved that vision from, geez, it was every bit of 3 years ago. If you, in looking back, I know once you got into this development, it was a small and exceptionally bright group that you worked with. Do you have any kind of lessons about undertaking something like this for the people here?
I don't know here, of course, but I'm always stressing that the digital humanities is quite a serious stuff and quite challenging. It's a place of competition, of new competition among cultural institutions, and maybe the assets that have been established in number of volumes or number of items so might be totally overturned once that you enter the web, where you may have no object, but might be much more an impact than huge institution. The passage, as has been said before by John, I totally subscribe, is that you need to have inside the institution a group of people that dialogue every day with the producer of content and adapt, try, make first trial, correct, and arrive at a final good solution. This is very uncommon yet, I guess. I don't know the situation here, of course, but in Europe and in my country especially, I can say that we are the only cultural institution in which we have this situation. I don't think there is a second one. And I believe that this is a key passage if you want to find digital humanities becoming an engine that is producing, attract interest, give life to a declining interest in the humanities, and also a powerful teaching tool. Powerful.
Yeah, we tested this with the Teachers Institute here, and this summer in its not quite finished form, and they do a section on Waldseemüller as a primary source teaching tool, and they were just, this was just an amazing. Even some of the teachers took it back, and there's several teachers in Missouri and Nebraska who, at the beginning of the semester, have been using it on high primary and early high school students, and it is just working out phenomenally. And so now that it's been launched, it can be used anywhere. But I think that's where its primary thing will be. But also, not everyone. There's a lot of historians of cartography in this room right here. I bet you I could take maybe 2 or 3 who would be able to tell me how Ptolemy drew his projection. Maybe Joachim would be able to actually do it with a compass, but otherwise it's pretty much not well known.
I have to say that this happened actually when one of the historians of cartography came to us and saw these animations. I don't make a name now, but he commented, finally I understand what Ptolemy had in mind. No, because this is the truth. When you read a text, you imagine something, but it's not exactly what is written there. If you see something translated in images, you have a better idea. Of course, if the translation is made by people who are accustomed to work with images. I was trained as an architect. This is why I could do this kind of job. I think it's not common to do this if you don't know geometrical projections, because of course you need that kind of preparation in order to explain graphically something which is only written, like in the book of Waldseemüller.
Yeah, in my rare book school class, I have my students sit and actually draw the second projection with a string and a compass. And, it's just forcing people to do geometry and that sort of thing. And this is just, I think it's an amazing resource. So.
As a question that has been raised about the model that we mentioned before, I think that those who yesterday heard Dave Sobel giving the lecture, of course, one field in which you may immediately translate the structure is celestial cartography, obviously. You take the Cellarius, or you take the famous maps are crowded with information, with a cipher for common people, and you can decode that and use exactly the same structure because there are observational instruments, measurement instruments behind. So it's very much, I insist on that, a model. Maybe a wrong model, maybe certainly an improvable model, but is a model that I hope will be used for many other things.
And I guess we could take one more question, or if Laura, you have another comment, or Stephanie, go ahead.
Yeah, thank you. I just want to start by saying I've been involved in digital humanities from when it was called Humanities Computing in the 1990s. And so I've seen a lot of projects. I direct a center, Digital Humanities Center, and I just want to say how astonishingly excellent this is, and also to thank you for the gift that this is, being open access to the world of learners and scholars. And then just to jump to one little question, in some of our projects now, we're trying to explore how to make transparent the scholarly process of debate and controversy, interpretation. I'm wondering if your site does that, or if you hope to do that, to have different scholars weighing in and debating or publishing some of their interpretations.
Next time we will give a better look to the Galileoteca, which I gave you a few slides before, which is online already, so you can use it. And in that application, we have tried to answer your problem. Any user can store in the system his own comments, can even publish a paper inside. And this means that around the knot of the application, you have people who have come in and said, I don't think it's right, I think that your interpretation should be changed. And this is growing with the archive and will be available for all the users to come after you have stored your remarks. And this is making a living engine this thing, because the risk of this kind of application, this technology becomes so quickly obsolete, information is growing, and the only way of keeping that update is to make a community tool of this tool. And so we will certainly work on that aspect in the future, even for this Waldseemüller website.
Well, thank you both, and move on to our last talk of the conference. Well, I hope you all go home and perhaps get some sort of large takeout and some sort of large supply of alcoholic beverages and play with the website for the rest of the weekend. Our last talk at the conference, there's one of the most unappreciated or unseen divisions here at the Library of Congress is the conservation division. They work pretty much behind the scenes, but they are really critical to every single thing that we do here. It is a small team of extremely talented, extremely dedicated scientists / artists / curators, all molded into one place. And this afternoon we're going to hear, or this morning we're going to hear a short talk by the chief conservator at the Library of Congress, Elmer Uusmann, about what it really took to encase and preserve the Waldseemüller 1507 map as it is displayed in the galleries upstairs. When you walk up to that case, there is a huge amount of technology that is sitting behind that case that keeps that map as it is and allows us to keep it on permanent exhibition. Elmer has done conservation on paper. He's a paper conservator by training. He's worked at museums all over the world, from the Reich Museum to the Metropolitan Museum of Art to the National Gallery. He's worked on prints from the Renaissance, which is his specialty. So without further ado, I give you Elmer Uusmann.
Thank you, John, for that very kind introduction. And gosh, thank you for setting me up, because I'm going to be the guy with the simple PowerPoint, so I'm sorry for that. We are conservation after all. So, making the case, sealing the deal. Making the case, not only literally making the case in which we're going to be displaying and storing the map, we're also arguing for the fact that this is what we need to do. Sealing the deal as in we're going to seal the map in a hermetically sealed case, but also as the last station in what was sometimes an arduous process in the library's ability to finally acquire the map. So I thought that was pretty clever. Okay, all right, moving on. So as John said, when you visit the library's Northwest Pavilion and go through the Exploring the Early Americas exhibit, you will find at the very back end the Carta Marina and the Waldseemüller map displayed right next to one another. And for all intents and purposes, that is exactly the same setup for both. Same display case, same low light level. The big difference is that one of them has a big amount of technology behind it, and that is because, in this case, the Waldseemüller map is the real one, the Carta Marina is a facsimile. And so, as John also said, this gives me a great opportunity to talk a little bit about what transpired and the work that went into it to get us there. And it was a 3 years worth of work. So let me first quickly share with you why we did what we did. So I don't have to tell you the importance of the map. I don't think that was well covered yesterday and today. But there were some additional directions, if you will. The US Congress provided about half of the purchase price of the map. So they were a big stakeholder. The German government was also a big stakeholder because they needed to be willing to provide the export license for the map to actually come to the United States. And both these institutions expressed a desire to make the map as widely accessible as possible. So that's an important concept. All right, we're going to share the map. That does not make conservation always very happy. So now we're in the classic dilemma between access and preservation. So the main problem with display is the accumulated damage from light. So light transfers energy to matter. And the higher frequency, the smaller the wavelength, the higher the energy, more damage is being done. Ultraviolet light does more damage to artifacts than regular light. Think of your newspaper in sunlight. That's the idea. That's what we want to avoid, and that's easy to do. We can filter UV light out fairly comfortably. But even regular light will still do damage. So we want to take that out as well, but then we can't see anything, so that doesn't work. Lucky for us, oxygen plays a critical role in this process. It's a photolytic oxidation process. So it stands to reason that if we take oxygen out of the equation, then we have a little bit more liberty in trying to see if we can do something for a long-term display. A long-term display is really anything that is something beyond 6 months. Most things, traveling exhibits, we usually try to aim for about 3 months. So we are here in our 10th year, so we're really talking long-term display here. We do have 2 strategies here at the library, and that is we have cooled cases. For those of you who have already walked through the Great Hall, you will see there are 2 Bibles, the Gutenberg Bible and the Giant Bible of Mainz. Those are slightly different cases. Those are cooled to about 50 degrees Fahrenheit. And the concept there is we slow down degradation mechanisms in general by cooler temperature. But we have the ability to do that because we have multi-volume Bibles that can be interchanged, and we can also change pages. That was not going to be an option for the map. And so we really wanted to pursue this oxygen-free, hermetically sealed case. So that's great, except we don't have that technology here now. Actually, we didn't have that 10 years ago. Lucky for us, there was a government institution not too far away, Gaithersburg, just outside the district, called National Institute for Standard and Technology. And they had just done the very thing for the Charters of Freedom at the National Archives and Record Administration. Charters of Freedom include the US Constitution, Declaration of Independence, and they had just wrapped up this project to replace the, I think they were originally built in the 50s, these encasements, and they made brand new cases. Unfortunately for us, a lot of these members that worked on that project had retired by now, but we could still snag 1 or 2 of them, and they were instrumental in helping us build these cases. So we have the map, we have stakeholders who really want this to happen, we have conservation willing to work on this, and the one thing that we're missing is funding to do this project. And that happened in the generous donation by Miss Virginia Gray and the Gray family, who established a Waldseemüller Support Fund in honor and memory of Martin Gray. There were additional sponsors and additional donations, but it's safe to say that without the Gray family, this case would not have been built. All right. So a hermetically sealed case has several challenges. I'm going to try to explain this a little bit. Hermetically sealed really means no air goes in and out. And as most of you know, air will expand, or gases will expand when temperature rises. And gases inside a hermetically sealed case will be affected by barometric pressures. A low pressure system will allow a hermetically sealed case to expand, and a high pressure system will do the exact opposite. So both temperature and barometric pressure are a critical player in this. If the pressure or the pressures combined get too much, the seal will break. And the whole notion is that the seal needs to stay intact to keep the oxygen out. So the case has to be able to withstand these pressures and has enough flexibility to do that. So that was the first thing. It was great that NARA, or that NIST and NARA could work together on the Charters of Freedom, but they were nowhere near the size of map we're talking about here. We're talking about 50 square feet. We're talking about an encasement of more than 400 liters. And this completely dwarfs anything they had worked with NARA. Another challenge was the fact that we could not use the same seals that were used in NARA. In NARA they used metal seals, metal O-ring seals, and for those seals to work, an inordinate amount of pressure needs to be applied. That pressure will also be put upon the glass that is right in front of the case and makes the glass crack. That already happened with the smaller cases. With a larger case like this one, this was simply not an option. So this needed to be thought through. Let me see. Yeah, I cannot stress enough that the size of this case was going to be enormous. So great, we have a metal box with a piece of glass in front of it and it's sealed. So how are we actually going to mount a map inside of that and secure it? That was another question. And then the last item is, how are we actually going to monitor the conditions inside the case? So we need to look at the oxygen levels, we need to look at the temperature, we need to look at the relative humidity, and again, we need to look at what we call the differential pressure. That is the amount of pressure inside the case. This is going to be a key component because we don't want the pressures to go over a certain threshold and we lose the seal. How do you add all these components and not add more factors that could make for a leaky case? Anytime you put a sensor in this case, you create another potential opening or a seal that can break. So, complicated matter. A lot to do. But at the end of the day, as a project manager, we only have one goal. How do we design, fabricate, test, and install this exhibit case with the map inside? That's the goal. There were additional objectives. There were a number of scientific, conservation, but also really purely project management considerations. And I just mentioned the last one. I think is always important when you do this sort of stuff. How do you make sure that every team member not only feels involved, but by the time the project is done, not everybody's so stressed out that they're tearing their hair out and just want to run away as quickly as possible. You know, manage your project carefully, basically. So one of the first steps is to determine what are the requirements for this case. So we already talked about a number of these things. It needs to be, of course, structurally sound. Not for obvious reasons like we need to be able to transport it. We cannot build it here. It has to be built elsewhere, so it needs to be structurally sound. But it also needs to be structurally sound that it, again, can withstand these pressures. If we can tiny cracks or hairline fractures, again, we're going to lose the seal, and that would not be the right thing. We need to, at least as a requirement, we said keep the oxygen level below 0.1%, and we need to have that, we need to keep that environment for at least 10 years. This is going to be a big operation, and we want to make sure we don't have to do it more than every 10 years. Needs to withstand atmospheric pressure changes. It needs to be as light as possible. At the time when we started the project in the fall of 2004, we did not know where this encasement was going to be located. So it could be in any of the 3 Capitol campus buildings, could be in the Jefferson building, as it turns out. And then we are highly constrained with how much weight we can put on the floors. So light, we need to be able to fit it through wherever it's going to come through. And then we need to put the map in an upright position. And just think about the size map that we have. We're going to make a metal case around this map, and we do that in a flat position. So how are we going to get it upright and keep it that way and have it and do that in a secure way? So, a couple of starting points. The case we're going to make is not going to contain any welding. This is not going to make for a structurally sound case. This, with the pressures involved, that was not the avenue that NIST wanted to pursue. No bellows. So bellows are a method to account for the pressures that this case is going to be withstanding. So it's basically a balloon or a series of balloons that are attached to the encasement, and anytime the gas expands, some of that excess air goes in the balloon versus the encasement. There's some problems with the bellows systems. They're finicky, they're hard to maintain, and they might not always perform as well as we would like to do. So NIST really wanted to step away from that and said, we're not going to do that. We're going to actually build a case that's going to have the bottom so thin that it will actually be flexible enough. So consider a metal bottom that's going to be flexible enough, and I'll show you in a second how that works. And then, as I said, the metal O-rings are not going to work, so we're going to use 2 O-ring, Viton O-ring seals, and I'll show you how that works. Viton is a synthesized rubber used in the aeronautic industry as well, and for our purpose really perfect. So I'm going to show you a series of drawings that will give you a bit of an indication of what the makeup of the case is. So at the top, and I have my handy dandy laser pointer here, sorry. Here we go. So at the top here, you see the encasement from the side. So we have over here the encasement bottom, and this is the frame that will hold the glass that goes on top. So you see the whole package from the side. Here at the bottom, I've sort of blown it up a little, open it up a little bit. You can see a cross-cut of the encasement bottom. Then right on top of that is the platform. The platform will eventually hold the map. On top of that, the glass, and on top of that, the frame. Okay, so this is highly schematic. I'm going to focus on this portion of the encasement. So keep this shape in mind. So as I said, we're not going to do welding. Instead, we're going to take a monolithic block of aluminum alloy, and we're going to mill it down to the shape in which we want to, the shape that we want to create. So this monolithic block of aluminum alloy was actually donated to us by Alcoa. And, well, you see the size there. I'm going to make a comparison here. This is about 256 gallons of milk, or a mid-sized car. That is the size of aluminum block we're talking about here. Okay. And so what we're going to do, we're going to mill this into the shape that we desire. And on the right side, you can actually see how the platform was milled at NIST. So the milling of the bottom that I showed you earlier, and that is the big block, was actually done at Becton, which is, Becton is just outside Washington, D.C. as well. And they shaped that, but at least you get a little bit of a feel of the size of the project, or the size of the case, because that is the platform. What they're milling in this platform, which is a relatively thin sheet of aluminum alloy, what they're milling there is little weight-saving pockets. So the structure of the platform stays intact, but you scrape away excess weight. So some serious excess weight was scraped away by the end of the process. So I hope you can see that we're getting to that shape that I pointed out earlier of the main block that we talked about earlier. So it was about, more than 90% of the block has been scraped away. I was thinking about that last night, and I thought, gosh, they must really have a good recycling program there, because that's a lot of aluminum. What you see from the side here are two of the grooves where the O-ring seals will be positioned. And I'll talk about that center channel in a second. And you can see the channels here from the top. Okay? And you can also see how a lot of the aluminum was scraped away here, and you get sort of that rib structure on the side. So this makes for a really rigid structure without having the weight needed to do that. So then we have to have a little bit of bulk here to keep the structure intact. And then here we have that flexible bottom. So that 4-inch aluminum block has been scraped down all the way to a 1/4 inch. And that 1/4 inch, because the encasement is so big, will actually flex up to about 1 inch in the center. So that's how much aluminum can flex. So then in this picture, what we're showing is the next step, and that is the platform. And on the platform, we will have two carefully selected and tested cellulose boards, and on top of that, we will place the map. So that you can see here the Japanese paper hinges that we're using with wheat starch paste to mount the map. The map is then hinged to the board, and the board, so here's the platform. The board is actually 2 layers of board. The screw goes through the first one, at the bottom one, and the top one, we make careful incisions, and we lift a little flap off the board, screw both layers in, and then put the flap back. So this way, none of the screws will, or any metal for that matter, will touch the map. So then the next step is to put the seals in. So these are the long, almost O-ring rubber bands, people. You can see here Richard Rohr, Dick Rohr, and Annelien Kruger, one of our conservation staff, and Dick Rohr was one of the main engineers from NIST, carefully threading these seals into the top of the bottom. And here they're sort of placed. And then the next step is to actually put the glass on top of the whole thing. So the glass was held by the frame. And the way NIST figured this out was to put little Teflon clips, dozens of them, around the perimeter of the frame that holds the glass, and when the glass goes down, it will rest on the seals. And this is why this hole is right there, because that will hold the Teflon clips. This center channel will be used to actually do the leak testing, because what we're going to do, we're going to push helium gas into this channel, and we have a leak detector, and whenever helium is detected, it will tell us whether the seal is actually working or not. Oh, sorry, let me just quickly go back. So I cannot really see this very well, but I think this is NIST and their workshop in which they did most of the testing. And I now also see this picture. It is sort of interesting, you know, the problems you run into during this type of a project. So the glass broke in two ways on us. First of all, it was very kind of Solutia to donate the glass, but it arrived in a nailed-together A-frame. And by the time it arrived at NIST, 7 of the 9 sheets had completely fallen over in the truck and were completely useless. And the 2 that were left had already little nicks, and so were also useless, because you cannot have even like the smallest nick in this glass. So we had to ask, well, that's great, but could you send us another couple of these? And they very kindly did. And then at NIST, we actually also broke another sheet of glass, again, because the bolts that I will talk about in a second had been too tight, and so it was a little finicky. The glass, by the way, is what we call hurricane-proof glass. It is a laminated sheet, so it is 2 layers of glass with a laminated layer in between. So also able to withstand quite some pressure. So this is then what the profile looks like. So we have the encasement bottom, we have the platform with the map. The platform is secured with what we call a trim bar, so that secures the platform. The glass goes on top with the frame, and you can see that the gas inside would have to pass these 2 seals in order to, have any air exchange with the ambient air outside. So these are the 2 seals that really make the case hermetically sealed. So then what do we need to do? Well, we need to bolt it all together. So there's 92 bolts that go around the perimeter of the map. And then we have to have 2 ports for gases to be introduced into the system. So one for the helium channel I explained earlier, and this is for the main chamber. And these main chambers, I should have drawn this, but the main chamber, they are communicated to one another. So there's not 2 chambers here, they're really one. So that is not, in principle, that's sort of the same way that NIST did this at NARA. Our challenge again was, of course, the pure size of the thing. So we really need to think. The glass, I'm sorry I should have said that, is about 165 pounds. So we just simply can't lift that. And the frame would have added another 85 pounds. So we needed to find a way to how we're going to put the map in, how we're going to put the glass on top, and how we're then going to display the map. So this is the part where the map can be introduced to the encasement bottom. And then this whole cart, if you will, can get wheeled underneath. And the frame is actually temporarily held on what can be best described as some table legs. Okay? So they will be removed later. The frame also holds the glass. So the encasement will be wheeled underneath with some scissor jacks. The encasement will be lifted until it will actually lift the frame with the glass and the table legs. Now it can be secured and the table legs can be removed. And once that is done, then we can add more scissor jacks and get it in an upright position. This is highly simplified. This actually includes several scissor jacks and several stages, but this is about the way. It's a slightly steeper angle as I could draw it here, but we could not go any further because then we had to really put, secured with the front, and that just wasn't what we wanted to do. So hence the angle, which is not great for display, but there was really no other way to do it. So there you go. So that was the total package. That is the total weight. That is the best we could do. And it's a small, compact car. That's what it comes down to. So that meant we had to get in the big guns because we clearly don't have an ability to do that. So we had a rigger company come in. You can see the two packages on the flatbed truck. One will hold the base that the display can be turned upright on, and the other one will hold the actual encasement. Flatbed truck, big crane, had to go in through the Great Hall, second floor. There was no way that we could get it up the steps. And so here you see some of the folks trying to carefully, once this crate goes in, very carefully move it inside. And then, of course, we had to deal with the mosaic floor, so we had to create an entire path to make sure that none of the floors were damaged. And then once it came into the Northwest Pavilion, we had to actually get a crane, or create a crane, to get the items out of their crates. But everything went beautifully, and no hiccups there, so that was fantastic. So the next step was to have conservation crew, and I had a lot of fun. This took about a day, but it was really great, to clean everything. Now, NIST had done some cleaning, but we just wanted to really go over everything with a fine-tooth comb. We didn't need a clean room. There was sort of an assumption on both sides, well, we need a clean room. We thought we needed a clean room because of the seals, and NIST thought we needed a clean room because, well, you want to do this in a clean room. This is conservation. This is a thing. And we said, no, we don't need that. That's fine. And they said, well, we don't need it. It's not a metal seal. It's a Viton O-ring seal. That's much more forgiving. We don't need that. So we could just do it in the exhibit hall, which saved us a little bit of work. So here you have sort of a good first image of what the encasement looks like. This is the base. You have the encasement bottom, and you have the frame on table legs that holds the glass. So while that was done, the platform had already arrived earlier at the library because we wanted to get the map ready. So what I showed you in an earlier image where we hinged the map to the board, to the platform, we were well done by the time the encasement came in. So here it's wrapped up, and conservation staff is walking it through the various tunnels to come from the Madison building, where the conservation division is located, to the Jefferson building exhibit hall. We had done this path several times because we really wanted to make sure it fit, so we, again, did not run into any surprises by the time D-Day came around. So then on D-Day, the map is ready. It's on a temporary stand here. Here is the encasement, so the map is going to be placed on a platform, is going to be placed inside the encasement, and that's going to be wheeled underneath the glass. So here's the map installed. The seals can't really see, have the seals? No, the seals are still about to be added. But here we're screwing in the trim bars to secure the platform to the encasement bottom. Okay, so now seals have been added. And now we're going to very carefully wheel the entire package underneath the glass. So we had to do this a couple of times. Clearly this is very heavy. You're sort of in a rut when you start moving it, and you have very little time to adjust it. So it took us a couple of times. But then it finally worked. So then it's a matter of bolting the 92 bolts. And here you see a final picture. I think this is AP. It was a bit of a media circus. There was a lot of press there, so that made the whole thing a little bit challenging. But the good thing was everybody knew what to do. So the whole thing was done in the morning. And in the afternoon, we could already start the purging process and getting the oxygen out of the case and starting introducing argon. Just one thing about the bolts. The bolts are tricky because along the long sides, we need more pressure than on the corners. This is what they figured out when they broke the glass at NIST. And in order for that not to happen, they have these little gauges that are very precise distance gauges, and so they know exactly how much pressure to put on. And that way, the seal is perfect and has not cracked the glass as of yet. So as per schematic drawing, I showed you how then it's being turned upright, and now we can start the process of purging. So we're going to introduce humidified argon gas. We cannot just put pure argon gas in there, that would be too dry. So we have a little system that takes the argon gas through 2 flow meters, and it will bubble, one of them will bubble through water, and then we have a measurement device that will get the relative humidity to about 40%. And so that 40% humidified argon gas will be flushed through the system, and then will come out of this end of the manifold. So this is called the manifold. This was first thought of by the former Preservation Research and Science Division Chief here at the library. And what this enables us to do is to have all kinds of measurement devices and monitoring devices connected to the manifold and not to the case itself. Because anytime we want to put a measuring device to the encasement itself, it'll create another hole and another possibility for losing the seal. So what are the measuring devices that we then put on the manifold? So we have 2 oxygen measurements, monitors. We have humidity. We also have a barometric pressure. It's not connected to the case, but we do want to know what the barometric pressure is going to be. And then we have the differential pressure monitors. So these are backups of one another, but these actually have 2 distinctive different functions. So we have a measuring device that measures the oxygen level going from ambient, which is a little over 20%, to about 3. And then the next one will take it a step further and takes it all the way from 3% to 0.1%. And the pressure sensors are finicky. It's very easy to get pressure sensors when you have a flow of air. It's much harder when it's stationary. And that is something that subsequent generations of these encasements have been struggling with. And that is something that the current Chief and Preservation Research and Testing is very busy with. So why is it important that we do all these things? Okay, so relative humidity won't change. Temperature won't change too much because we're pretty well able to keep the exhibit area at a very steady temperature. So that part's good. But we can't do anything about the weather. We wish we could. So barometric pressure will change. And so that is in this graph. Sorry, there's a couple of graphs and then that's all, and I'll be done. So there's barometric pressure lined up here and temperatures lined up here. So it's not really vacuum engineer. The engineer that really helped us, Dr. Charles Tilford, with establishing and monitoring this environment, made this graph, and it shows you the safe zone, if you will. Now, if the temperature is pretty much going to be constant, then we really want to follow this line, if you will, to make sure that the encasement interior stays safe. As soon as temperature rises, we're going to get in this area, and as soon as it drops, we're going to get there. Or conversely, if barometric changes will get us into a red area, either too low or too high, the same will happen. So we're keeping a close eye on barometric pressure. So this is March 2008. The installation of the map was complete in 2007, December 2007. So this is a couple of months later, and it gives you an idea of the range of barometric pressures that this case experiences on a daily basis. But since like I said, the temperature is constant, it's really only the barometric pressure that's going to have an influence on the differential pressure inside the case, and in fact, directly so. So when one goes up, the other one goes down. So if I have a low barometric pressure system coming through, my case will balloon, and conversely, with a high pressure system, it will contract. So that looks really bad. But the nice thing about graphs is it's all about scale, right? So now it doesn't look so bad. And we are well within the threshold that NIST established of 25 millibars that is considered to be the safe zone to make sure that we keep the seal. So there are, however, some doomsday scenarios where we could, go beyond that. So that would not be good. So one of them would be if a beautiful winter day, high pressure system coming through, and for some odd reason our heating drops out. So temperature drops, gas contracts, high pressure from atmospheric pressure coming in, that could, crack the glass. This is not so likely to happen. This could possibly happen. I won't say we haven't gotten close, but we've kept an eye on it. A low pressure system like a Hurricane Sandy lands in Maryland versus New York, coming through. All the terrible things that happen during those occasions might happen. We might lose power, so our cooling drops out. So our case temperature might rise. We have a low pressure system coming through. We might lose the seal. So it happens. So don't imagine that the glass will shatter or anything like that. But what could happen is that we get a little crack in glass. It is the pressure that will cause that, and we lose the seal. So that's not the end of the world, but it's a bit of a pain to start the whole process over again to replace the glass. So we have a system where we get emails when circumstances are threatening to get us close to that happening. And once we do that, or once we see that it's getting a little too close to comfort, we just open up the main valve, and we'll introduce ambient air into the system, let the case sort of settle down. Unfortunately, we no longer have an argon environment, but we can reflush the case and start the process over again, and it would save us from having to replace the glass. Now, just in case, we do have a piece of spare glass sitting in our warehouse, so we could do that, but we'd really like to avoid that. So here we are, it's all set. All the monitoring devices are sitting on the back. You can't see them, but trust me, they're there. And here's John overseeing everything. And so this is where we are right now. So, like I said, successfully completed in December 2007. The seal performs much better than we had possibly imagined, which is great news. And we thought it's going to be 10-year seal. It's definitely going to be 20-year seal, or 20-year seal. And maybe by that time we actually have to replace the O-ring, the Viton O-ring seals. It's not anything to do with its inability to keep it. And another objective that I'm very happy about is the fact that we have now obtained in-house ability to monitor conditions and remedy situations if necessary, and reflush the case as necessary. I'm not saying that we could build a case like this, but we can certainly maintain this one, which is great. Big project, lots of people involved. I'm just one of them, and these are all the folks that had all of them a critical part in this and make this happen. That's really it.
So Elmer will take a seat and pick up a mic and do any questions if you'd like, if there are any questions.
Yeah. Just cannot see anything.
Question for you, going back to your very first slide. There was a question here about access to the original document. I'm thinking back to, I've been around here for a number of years, and the Watershed Map Society, and had a chance to see the map before it was encased. I know that John Hessler and Chet Van Duzer have done a tremendous amount of research on that map, the original map. Books have been published, and all of this has happened. In the years since this map has been encased, Chet has gone on further, using multispectral imagery and all kinds of other things with the Martellus map and other documents. What provision is there, as the technologies get better and better to understand maps and research maps, what provision is there to take the map out of the case at a certain point in time to do additional research and then perhaps remounting it in the case?
You have a decade?
No. Well, I'm glad I'm not making that decision, but I would say that we could do that. Well, a couple of things. Hyperspectral imaging has been done off the map before it went in, and that's all thanks to Dr. Van Elle-France, who made sure that that was in place. So we have high-resolution images at different bandwidths. Could we take the map out? Yes, absolutely we can. And in fact, NIST makes sure that we had a way to do that. It'll be wheeled out, it'll be flattened. We get the table legs out, that they're still there, and we can do that. But it's a big production. And it will probably take some direction from people that are not me to say, you know, it's really time for us to have another look at it, and it's important for us to pursue this. We can certainly facilitate that, but it is a bit of a production.
Yeah, and Tom, I think when we put it in, we can't really foresee any research reason that we'd ever have to look at it again. If we do look at it again when it comes out, it's going to certainly be another round of hyperspectral imaging from a conservation perspective to see whether there's any changes or anything like that. But I think when we put it in, we really, after doing hyperspectral imaging on it, couldn't foresee any real reason that we'd ever have to take it out. We even have things like fiber samples that were saved, ink samples that were saved. in case there was future testing that might need to be done on it from that perspective. But I think it's in there for another decade. So,
yeah, I also want to say on a personal level, as fun as this project was, I am not, I'm not a big proponent of this at all. I think if it was up to me, I'd take the map out, put it away, and put another facsimile up. So this is not a conservation-driven project, but it is certainly a conservation-guided project. And, the driver here was the desire to have this on long-term display to increase access, not just for scholars, but really for the public.
Ben?
You talked at the beginning about light damaging things. So, and there are ways of dealing with that in terms of controlling the wavelength, et cetera. But looking sort of to the distant future, what's another hypothetical model where you could illuminate the map with really minimal damage? I mean, light wavelengths are always going to be light wavelengths, but is there any sort of hypothesis about, or conjectural model about a different way of illuminating?
No, it's a fundamental principle that light carries energy, and it doesn't matter whether you illuminate something on a light level or there's sort of low light levels or high. It's the accumulated effect. It just builds up and it keeps going, and the process will just take it will proceed a lot faster under certain circumstances and higher energy wavelengths, but the principle remains the same. Yeah.
When you think about the reason that the map survived, in fact, it was because it was bound into a book and closed and put away and never saw the light of day again. So we have it that way. A curator, when they hear the word permanent display, or a conservator, you nearly want to, like, no possible way. We don't ever want to do that. And we also don't want to have the fact that, it's lasted for 350 years and us in 50 years, destroy it. So this was one of those very bizarre projects. And it really was driven by the agreement of purchase, which in fact required permanent display. So it was a big issue.
Yeah, John is absolutely right. Putting something in an album and having direct contact with the pages and putting something in is fantastic for conservation purposes. It's just, it's not accessible that way. As John said, it wasn't actually Renaissance prints, but Renaissance drawings in a collection in Rotterdam I worked on. There were 200 of Fra Bartolomeo drawings, and they were exquisite, and they had never been touched. And the main reason is oxygen cannot really get to it, air pollution cannot really get to it, and they were in fantastic shape. But because they weren't accessible, and because they were chalk drawings, and every time somebody does go through them, pages flex and chalk will fall off, we decided, well, not we, it was decided that put them in mats. But ultimately, I think if they would have been kept in the album pages, they would have done great for hundreds of years.
David?
So you talked about a 10-year limit, maybe 20 years. It's a two-part question. As a conservator, would you like to see the map put away somewhere for safety? Mm-hmm. And might the new website allow that? Might that be considered access to the map that would satisfy the purchase agreement?
So the answer to the first question is yes, but but I need to be that advocate, right? And it's not my decision. It is just for me to say all things. Where I'm coming from is I'm not concerned with access. I'm concerned with preserving this for generations to come. But ultimately, it's not my decision. And then the only thing I can do is to say, well, okay, if that's what we want to do, if the need to make this accessible trumps my desire to conserve this map for future generations, then let me at least guide this project and do this in the most responsible way possible. Whether this website will answer some of this need, I really don't know. It's a big, there's a continuing discussion about, well, why do we just put up facsimiles of things? Because the light levels can go up, people don't know the difference. Why just don't you do that? That's ethically probably uncomfortable, and so we still do what we do. I don't know if that answers your question. It's a process. It's multiple people who are in the mix discussing and then weighing various options to see what would be the best thing to do. Now that it's in the case, I'm very comfortable with it. very comfortable with it for there to be another 10 years. And then I don't know whether we will renew it or whether we, by all that time, have decided, you know, we've done what we set out to do, and I think it can go back now. I don't know.
One of the unfortunate things that this case has done, and the documents at NARA have done, is they've created a monster. At least I think so, because everyone who donates an expensive map says, oh, I want to put it on permanent display. And so we know you can build these cases, and so, again, as Elmer said, these decisions are made way above our. We can advocate, we can say we don't want to, we're not comfortable, we don't think, but in the end, if the money's raised and they say we're going to do it, we have to do it in the best and safest way possible. So I would take it out tomorrow. If it was up to me, the map would be removed from display and placed back in the book, and the book would then be displayed every now and again. And we could have the website in a facsimile. But again, above our pay grade.
Could you just tell us a little bit about the material on which the map is printed, the paper? What is your analysis shown?
I cannot really. I mean, it's very stable, 15th century paper. We have certainly looked at the watermarks. I'm not the expert on this. I don't know whether Sylvia or Heather is here or whether they're willing to say anything about that, or I can put you in touch. But that is not knowledge I have on top of my head.
Why don't you just come up, since you're... No, you're standing there. Come on, you may as well.
Or maybe afterwards.
Or maybe you just want to talk afterwards?
Yeah, that makes more sense.
Okay.
Yeah, that sounds good. Okay.
Any other questions? Oh.
Thank you. Thank you very much. I'm Sylvia Albro. I'm a paper conservator working under Elmer. And when the Waldseemüller map came in, I know that Heather Wanzer, another senior paper conservator, did do beta radiographs of all of the pages. So we have a record of the watermark, and we know other maps printed by Waldseemüller are on that same paper. It's a very, very high quality paper, high calcium content. There's a bit of an uncertainty of whether it comes from the region of Alsace or northern Italy. It's a crown watermark that's been used in other Strasbourg-based publications, so information is out there.
Yeah, the watermarks are rather strange. It's a pair of crowned watermarks. The watermarks that are found on the 1507 map, not all the sheets have watermarks, but the ones that are watermarked are these pairs of crowns. That watermark also appears on the Carta Marina. That watermark also appears in the 1513 Ptolemy by Waldseemüller. So the three major Waldseemüller extant publications have that watermark. Sylvia and her team, who had a Ptolemaic Atlas study team in the conservation collection, conservation division, recently discovered a rather strange thing that scholars are going to be puzzling over for a long time, that watermark also appears in the Nuremberg Chronicles. The connection between those two is unknown and peculiar, so that's kind of where we are on the watermarks. And anyone else? One more? Well, I want to thank you all for coming, and I want to thank Elmer for and I also want to invite you all at between 1 and 3 this afternoon in the Geography and Map Division, which is in the basement of the Madison building. We will be having an open house. At that open house, the original Sammelband will be on display. So if you want to see the original book the 1507 map was in, which still contains the Carta Marina, which still contains the globe gores, you can see it there. We will also have many Ptolemaic atlases out, and also there's a little bit of a strange thing on the Carta Marina, which sheet 6, there are actually two sheet 6s of the Carta Marina. One is printed, one is a manuscript drawn in the hand of Schoner. that will also be on display. So we invite you down to the Geography and Map Division from 1 to 3, and I want to thank you all for coming. Hope to see you there.
This has been a presentation of the Library of Congress. Visit us at loc.gov.